So as a primary thing, as part of my job profile, I actually look at how we can bring the machine learning models and how we can scale up the analytics in an organizational scenario. So when we talk about analytics and when we look at multiple different things in the analytics, we do have a lot of softwares and a lot of infrastructures and tools that are available. However, majority of them are either costly, way too costly. For example, if you go with something like CloudFront or if you go with Databricks, it comes with cost. And it starts with the cost at the data storage level as well as the data acquisition and reading part and the processing part. And when you go with something like AWS or GCP or Microsoft, of course you will be spending a lot of your revenue in processing. So lastly, when I was looking at LLMs and see how we can run a simple LLM for 1 year, the average cost, it came somewhere around $90,000 to $120,000 with AWS, and that too with minimum of around 15 to 20 prompts, which is too huge cost for smaller organizations. And if you are a startup, you will not be able to proceed further with any of the things like GenAI or LLMs or even a simple machine learning. And as I am more interested in solving problems to optimize the usage of hardwares for such analytical activities, I took up a project where we have a lot of data. And one of the key areas where we will have a lot of data is, of course, our stock market. This is switched off. So what is more interesting in the stock market? We generate data every second. And even if I look at the data at a 1 minute interval, if you take a single stock, we all know that the market runs from morning 9:15 to evening 3:30. That means we have around 375 data points that we can collect for a single stock in a day. And if you take around 100 stocks, and if you extrapolate it, if you compute it for, let's say, around 1 year, then you will be ending up with 9 and n number of zeros. Actually 6 zeros. So this is the volume of data that you will be having if your granularity is 1 minute data and if you are processing the data for 1 year time period. And adding on top of it, the other challenge that you will see in the stock market is the data is not batch, it's real time. So you have a streaming data that is coming in and you will have to process it at as fast as possible so that you will be able to generate the signals or you will be able to generate the outputs at a much faster rate. So there are 6 different umbrellas where we will have the problems here. Volume of data, it's huge volume of data that we are dealing with. Next comes the storage. You will have to optimize the storage not only for reading but also for writing. And number 3 is processing. You are dealing with a large volume of data, so the processing of the data should be simpler and it shouldn't be taking a lot of time and cost. And on top of this, we have to do the analysis in real time as well as in batch mode and get the results out of it. So there should be flexibility for us to do both the batch processing as well as real time processing of data. Of course, the last one is real time. Anyway, I already mentioned the real time a number of times. So this is the problem statement that I was dealing with. And of course, this is not only a problem with stock market. Even if you go to e-commerce, you will face the similar kind of a problem. And if you go to IoT devices, especially when you start capturing the health records, you will face a similar problem. So this problem is not unique for the financial industry. The problem is generic. You can apply it in any different industries. And the challenge that I faced was that Data scientists used to work with a simple tool called Jupyter Notebook, and day in and day out their life is with Jupyter Notebook. They will not be able to do anything other than Jupyter Notebook. It is nothing but an IDE that can be executed as a service, and you can access it in the web format. Of course, there are other tools that are available, like the Python-based IDEs that are available, but predominantly data scientists are more used to working with Jupyter Notebook. And you should have the flexibility to run the notebooks as it is in the production environment. And you should also be able to run it in a batch mode and in a real-time mode. So the challenges becomes multifolded. So it's not real software engineering job, it's software engineering on steroids, where we have analytics coming in as a big mammoth giant living inside software engineering. And another interesting tool that the data scientists use is Pandas. Why are they using it? It's very flexible and it is easier for us to handle things, to do data manipulation and data analysis, and also for machine learning model building activities. They use Pandas. Again, Pandas is nothing but a data structure. So this data structure is used as a background tool to build machine learning models on top of it. So this is like a data storage system, an in-memory data storage system, you can call it that way. However, this guy has got challenges. So until some 5-6 years back, or until 10 years back, when all these machine learning models and when all these data analysis and data science was dealing with only the static data, which is done in a batch mode or in a background mode, and when we were actually handling it only for the reporting purposes, it was fine to handle with such systems like Pandas. But the moment we go into real time, and the moment we start using it for production systems, we started seeing a lot of problems. The major problem comes from the way Pandas uses its memory. It starts consuming, it's actually a memory hogger. What do I mean by that? It starts consuming memory as and when it starts growing in volume, as well as if I start doing any aggregations or any processings. So the moment I start doing multiple aggregations or multiple processings, then Pandas will start increasing in size in the memory. So what will it push us towards? I cannot use a simple system. I cannot run my processing in my local desktops. I am forced to get into cloud-based systems, and there again, I am not allowed to get into a distributed processing. I cannot use multiple systems to do my processing. Of course, multiple distributed processing itself is complex when it comes to aggregations, because aggregations are sometimes it is based on the group-based activity, or it is based on the time-based activity. And on top of it, if I have to distribute things and if I have to start processing it using Pandas, it is very tedious. And of course, we all know that Python itself in general works with a single thread. Pandas also goes into the same mode. So it works in a single threaded mode only. So even though if I have a little bit more powerful system, maybe with 16 CPUs and CPU cores and maybe even 64 GB RAM, I will not be using all the entire resources that I have in my system. So I am wasting a lot of resources. So that's what I was able to come up with when I was analyzing what was going wrong in this one. And there are multiple different alternatives that are available. So to name a few, I think these are popular ones that are available. Modin and Polars. These two are very simple and straightforward tool. Again, these are all open source systems. Nothing is commercial. So Modin and Polars are very simple and very straightforward for you to use. All you will have to do is that instead of doing an import Pandas, you will have to do import Modin, and then you will continue with the rest of the things. And similar is the case with Polars. But what captured my attention was DuckDB. DuckDB is also a contender in this same arena, but in a different way. So DuckDB will not give you the same features like your Pandas or like your Polars and Modin. But the beauty that DuckDB brings in is It brings an analytical engine, that is OLAP, analytical processing engine, into your system in the form of a database. So until now, we have seen all these analytical engines or analytical databases lying in a single system. For example, something like a Redshift or something like Hadoop and the entire Hadoop infrastructure, or it can be any other infrastructures that we will have, where we will be calling it as a data lake or a data warehouse or a data mining systems. But what DuckDB does is, it democratizes the data and give it to the individual analyst. That's the beauty of your DuckDB. And of course, it is open source. You can customize it, you can modify it according to your need, and you can change if you want the behavior to be changed. And on top of it, this is a vectorized system. Vector processing becomes much easier. A columnar vectorized system. So that's the beauty that DuckDB brings in. So you have a powerful OLAP system lying inside your machine. And whatever data processing that you are doing in Pandas, you can do a similar kind of a processing with DuckDB with a minor or minimum change in the way you approach the problem. So you are no longer dealing with Python, you are no longer dealing with Pandas. Of course, DuckDB is built on top of C++, but it brings in the sophistication or simplicity for you to process the data in a simple SQL format. So for the software engineers in this forum, it's more like you have SQLite for analytical processing. SQLite is again a simple binary storage system, database system that many software engineers uses when they are in the process of development, and it can be sent across or shipped across along with the software, because it's as simple as you having a text file and you are accessing the data from the text file. It's nothing but a binary file. And your DuckDB provides you that sophistication and simplicity to you for your analytical data processing. And on top of it, it gives you the vectorized format of processing the data. So if I have to do a natural language processing, or if I have to build a new Llama system, then I need not have to have a bigger system like 64 GB system or 128 GB system. I have seen even people using 256 GB systems. The problem is that we will be spending dollars and dollars of amount for these systems if you go with cloud-based infrastructure like AWS or GCP. But with DuckDB, everything comes into my laptop, and the beauty is that I will not have all the data available in the memory. Instead, whatever is needed, I fetch only those things. So that's why the columnar part comes into picture. So when I was doing the benchmarking of Pandas with DuckDB, there are 5 different perspectives in which I was looking at. Number 1 is performance. Number 2 is memory usage. Of course, I did mention about the memory usage, so I will not touch that memory usage part again. But when it comes to performance, I did notice that the time taken for the same activity to be done between DuckDB and Pandas was significantly reduced when I go with DuckDB. So if I think at the last slide I have a small benchmarking number, but to give you a perspective, DuckDB reduced my processing time by around 5 to 6 times compared to Pandas. And on top of it, I am able to use DuckDB in sync with something like Modin or Polars, which is actually a beauty for me, because I have the data locally available and I can take the data as and when I need it, and I can process it and I can save it back, and I can do all these things at a much faster rate without having any dependency with anyone else, any other third party. I need not have to go and then sit in front of my DevOps team, or I need not have to go and sit in front of my DB team to create a database or to create a table or even to delete few rows or delete few columns. So everything is available for me and DuckDB democratizes the data for me to process everything at a much faster rate. The query analysis, scalability are the other two areas that I was looking at. The querying and analysis, it is different when we go towards DuckDB. Pandas, if people have used Pandas for a longer time, they may struggle a bit to primarily move towards DuckDB. But if you are coming in from a background where you have used predominantly SQLs in the past, and if you have worked with Hadoop systems and you have written a lot of HQLs, that is Hadoop query languages, then it is going to be straightforward for you. You don't have to spend a lot of time in doing that. Whatever you can do with Hadoop or with Redshift or with any other database systems, you will be able to do the same thing with DuckDB as well.
But then why choose DuckDB rather than use Hadoop and all? Hadoop is also open source, I guess.
Yes, it is. The cost involved. You cannot run Hadoop in your local machine. And scalability. Of course, the way I have worked it out is that this DuckDB can run an individual's machine and also as a centralized system. We can have it in both the places, and I have integrated this with the Jupyter Notebook along with other plugins that they can use, so that we need not have to go for anything else externally to use it, and people can start using it as it is with the customized system that we have. To summarize, I think this you can read it. I will not touch here. I have the next slide where I have taken significance between the Pandas and DuckDB. Maybe I will go through that. Installation becomes very simple. All you will have to do is that pip install DuckDB and it will be installed. And if you want to go for open source and if you want to contribute, of course, the binaries are, the source code is available. You can go ahead and use it. It comes with the MIT license, by the way. And Pandas is also available for you, but it becomes heavier the moment you start integrating it with other tools like AWS S3 or Boto or any other things. Versatility. Python has got a good integration with any of the visualization tools. For example, Matplotlib or Seaborn or anything. Python has got a straightforward integration. DuckDB has not reached that level of sophistication like Pandas, but of course, yes, because it has integrations with Pandas, or because you can query directly from DuckDB to Pandas, it becomes easier for you to do the visualizations also. But on the other hand, DuckDB gives you multiple different platforms in which you can run it, be it the Python or be it Rust or C++ or Java, name it, you will be able to run it. And with respect to syntax, like I mentioned, either it can be a data frame kind of a syntax or it can be a SQL based syntax. And when it comes to performance, wherever Pandas was giving me out of memory exception, DuckDB was able to run it at ease without any problem, and that too in my local machine. To give you a perspective, this is the study that I did. I ran the same program across both with Pandas as well as with DuckDB, and what I noticed was that wherever Pandas was taking around 15 to 20 minutes for a single iteration to be completed, DuckDB was able to do it in 2 to 5 minutes. And the execution time, if you look at it, DuckDB was able to run at least around 1.1 to 1.5 cells per second. Again, here I am talking about some of the signaling techniques that we have. If you go with any of the technical analysis, you will be coming across something like a simple moving average or an exponential moving average or a moving window frame, or even it can be something like a Bollinger Band or any other RSI matrix. That is, so you will be able to see that DuckDB is able to give me a better performance, and this is done with 1 minute data ran across for around 5-year time period. Yep, 5-year time period. Sorry?
NSE or which stock exchange?
NSE, National Stock Exchange, yes.
So what's the size of the data that you crunch?
See, like I mentioned, you can compute it, right? So 375 data points for one day for one system. So you can see here that I have listed down some names. and all the names they run, they do traded every day and every second.
Yeah, but it will be around like some 20 to 25 GBR.
More than that. Easily, it's more than that.
So ballpark around, I'm suspecting around 100 GB.
See, if you look at OHLC, that is open, high, low, close, and volume, then number might be less. But the moment you get into data processing, you will be seeing that for a single signal like RSI, I'll be having around 100 to 200 RSI signals that is coming out. So from that perspective, data can grow more than what you are talking about.
So, like with this much processing, is it beneficial perspective? Like, there are some other US guys that established a company to beat the market and all, right? Those kind of mathematical processing can be done within our PC. Means, is it beneficial, like to gain some money over it? Like how can we move further forward?
It is beneficial. See, it's not about the processing that you are doing. It is about the analysis behind it. So what kind of analysis that you do, what kind of inferences that you gain out of it. So that's what will differentiate you from anything else. What I have shown here is the comparative study, not the analysis part.
So this visualization is done in DuckDB. If you want, you can port it to Pandas and work.
No, I have done it across both Pandas and DuckDB. What I have shown here is the DuckDB's result. I was actually thinking of showing the Jupyter notebook that I used, but I think it may not be possible for me to show now because I had certain analysis also embedded into it. So I thought, okay, maybe I'll show you this along.
So an organization which, for example, we are a logistics organization, and we have some problems which we feel like ML or analytics can solve. Now, how do you start working in that area? How do you, without having ML engineers, or how do you venture into this area?
Okay, it's a bigger problem to be solved. That is because the problem that we think can be solved using ML may not be a problem that will qualify for ML. So the first and foremost thing that we should look at is ML going to be a game changer for me? If it is so, the problem that I have chosen, is it the right problem? Or am I looking at it from the right perspective? Or should I have to change the perspective? So that's where I will start. And though we have a good problem in hand, most of the times what will happen is that we will end up with data that will not quantify or that will not support us to run the problem or support us to even approach the problem in a specific way. So these are some of the things that first we should clear out. Otherwise, what will happen is that most of the data science projects or most of the machine learning projects fail in the market, either because the problems that they have selected is not right, or because the problem is good, but they don't have proper data that is available. And of course, though we call that we are in a data swamp, what we see is that there are a lot of noise. So the moment we start eliminating the noise, we end up with nothing. So identifying whether we have gold mine or not is first to clean up the data. So once we clean up the data, then we will come to know, yes, whether we are actually getting into gold mine or we are getting into nothing.
Bro, I have a doubt. You said Python is single threaded, right? And we use Pandas, and Pandas is a memory hogger. So you suggested as an alternative to use Modin, right? So how do they solve this problem? Even though the underlying language that is being used is Python, right? So how do they solve this problem? Do you have any insights about it?
There are multiple ways in which they can solve this problem. It's not only Modin. Again, it comes with the way you approach the problem. So for example, see, I have not looked at what Modin does internally, okay? But I can tell you what something else is doing. So if I have to look at data frames in a distributed way, then people will talk about something called Dask. So there what happens is, they claim, that is Dask claims that I am nothing but a collection of data frames. So if you have one data frame that is big enough, you split it into 10 chunks. That is, for an example, let's say that you split it into 10 chunks. Then I can process these 10 chunks in parallel for you in different cores, and I can then do a collection of them.
But to achieve this, we need multi-threading, right?
That is taken care of internally with Dask.
Sorry?
That is achieved internally within Dask.
Dask.
Not only multi-threading, I can do a distributed processing. So I can have a Dask core, and I can have Dask workers, and I can process these data frames in the worker node and get the results back into the Dask core, and then I can do the aggregations.
So as per my understanding, it is like running parallelly few individual Python tasks and
Yes.
then combining the output together as
Yes,
okay.
yes.
Yeah, makes
So distributed computing, Dask is one of the example that I talked about, and another example that you can look at is Ray. Ray is also a good example. But honestly, I have not looked into what Modin does internally. The way I have looked at is that all you will have to do is that you will have to make one single change at the import level if you want to use Modin. Everything else Modin takes care of internally. I have not gone in depth into see what is happening over there. Alright, if no other questions, thank you. Okay, last question.
Does Duck have a NoSQL variant to it?
Which one?
Does DuckDB have a NoSQL variant to it? Or
I-
is it purely relational?
I will not call it as relational, it is analytical. So if you want to save the NoSQL things, you can do it, but you will not get the support directly like how you get it in Mongo or in any other systems.
Is there any similar projects can you suggest in DuckDB which has been done, which has been out there in GitHub so that we could refer?
There are many, you can search for it, you'll get. If you go to GitHub and if you start searching for it, you will get it. I think being conscious of time, I'll wrap it up here. Anyway, I'm around. If you have any questions, you can reach out to me. Thank you.